Hey guys, so just as I was assigning the delta math, I noticed that when it has you graph, it has you find the y-intercept and x-intercept of the function when you're graphing it. And I want to go over that. This is a really important thing to remember, and maybe you all know how to do it. If you do, go ahead and skip this. You don't have to watch this, but I just want to go over it, make sure that we're feeling good. So y-intercept, again, for the notes, just always good to have that review in case you're feeling a little rusty as well. Y-intercepts happen, right, when a function or, um, yeah, a function touches the y-axis. That's it. This is the y-intercept right here, okay? Um, Unique to, perhaps like one of the most important things about the y-axis, though, is that, I think it's lacking a little bit. Perhaps the most important thing about the y-axis, sorry, the y-intercept, is the coordinates. The coordinate of the y-axis, we know because it's on the y-axis, the x value is always 0, and then it will be some y value, okay? Um, on the other side, the x-intercept or intercept, um, those, or one or two or many, will happen when the function touches the x-axis. So here and here. And here, critically, the coordinates are some x value, but the y is 0. And some x value here, and the y is 0. So we know one of the coordinates, one of the x, we either know the x or y value for both the y-intercept and the x-intercept. If they have y-intercept, we know that x is 0, and then for the x-intercept, we know that y is 0. So this is a review. How does this relate to our problem? So I rewrote the problem from earlier so that we can find the x and y-intercept. So y-intercept, I would say, is the easier of the two. Y-intercept, we know that the x value is 0, right? So all I got to do is basically find f of 0, or plug in 0 into the equation. So I'm just going to kind of copy what's on the left there, and I'm going to get 3 times 0 squared plus 10 times 0 plus 8 over 0 squared minus 4. So that simplifies down to, right, because those are just 0, 0, red, 0, 0, 0. This just becomes 8 over negative 4. That simplifies to negative 2. Okay. Let me clear some of this out just to make this cleaner. So that means that my y-intercept would be at 0, negative 2, right? When I plug in 0, I get negative 2. This is my y-intercept. So y-intercept's easy in that way. If you're getting, as a result, something like 0 over 0, that's going to be undefined. Okay, so this would be undefined. There would not be one, okay? If you got a straight 0, so if you got, for example, 0 over 1, that is just 0. That is valid. But 0, 0, 0 over 0 is not. Okay. So that's y-intercept. Does that make sense? So to find the y-intercept, I'd like make a note of this somewhere. Just plug in 0 for x. Okay? Exclamation mark. Well, no. Okay. Now for the x-intercept, we know that that's where the output is 0. So essentially, again, I'm just gonna clean this up a little bit. Essentially, what we're looking for is when does this function right here, let me kind of highlight things I'm talking, when does this function here, when does it equal 0? When does it equal 0? I mean, take a moment, think about it. When does this equal 0? How would this equal 0? Right? Well, we don't want the denominator to be 0. That I don't care about the denominator really. I don't want it to be 0 because when you divide by 0, you can't do that. So I actually don't care about the denominator. What I care about, more specifically, we can narrow it down. I just want to know when this is 0, when the numerator is 0. So when is this 0? Okay, how do I find that? Well, that's when, once again, factoring comes in really handy. Um, you, I'm sure you did this, even if you didn't realize you were doing it um, in Math 2. This is our factored form once again. Remember, I don't really care about the denominator. Like I'm not concerned about it. I am concerned about the numerator though. Okay, so my question is, when does this equal 0? Right? Well, because of the zero product property, which says that if you multiply by 0, you get 0, I just need to know when this is 0 and when this is 0. When one of those is 0, I'll get 0 as an outcome. Okay? So what you do is you solve each of them for 0. You're finding the zeros. Okay? Minus 4, minus 4. 3x equals negative 4. Divide by 3. Divide by 3. X equals negative 4 over 3. That's one of them. Okay? The other one, easier. X plus 2 equals 0. Minus 2 minus 2. X equals negative 2. So that means I have a y-intercept, two y-intercepts. One of them is at negative 4/3, comma 0. The other one is at negative 2, comma 0. And those are my y-intercepts. Okay? When I plug in negative 2 back into this equation, I'll get 0.